I've been waiting way too long. Yeah, I've been down here trying to get it. Yeah, I've been waiting way too long.
All right, this is the video for 7.3 discussing similar right triangles. When the altitude is drawn to the hypotenuse of a right triangle, the two smaller triangles are similar to the original triangle and to each other. All right, so I have a right triangle here, triangle ABC, and I'm going to draw the altitude to the hypotenuse. So that's going to be from vertex C to the hypotenuse at a right angle, because that's what an altitude is. All right, so there's my altitude. I have just created now two triangles, and then of course I have my original triangle ABC. And so I'm going to call this point D. So now I have 4 points here. So I have created another triangle ACD, and then I have created this triangle CDB. So I'm going to go ahead and label that A, C, D, and C, D, B. All right, so these are obviously right angles. So now we're going to discuss what the triangles specifically are similar. So I'm going to write the similarity statement. So triangle CBD is similar to triangle ABC, and triangle ACD is similar to triangle ABC, and triangle CBD is similar to triangle ACD. So the first two are the two smaller triangles and how they're similar to the original larger triangle. And then the last statement is how the two smaller are similar to each other. So in the first statements, we can see that CB corresponds with AB. CB corresponds with AB. And that's similarity. So that means those sides are proportional. All right, so CB corresponds with AB. And then next, we have BD corresponds with BC. So BD corresponds with BC. And lastly, CD corresponds with AC. CD corresponds with AC. So those are the corresponding parts. The colors match up. As you can see, the yellow highlighted segments are the hypotenuse. And so they obviously correspond with each other. And then the longer leg corresponds with the longer leg in the larger, and similar with the shorter leg corresponds with the shorter leg in the other triangle. So that's how you can kind of identify which triangles are similar. We're going to do an activity in class that is going to help you understand this concept a little better, but please make sure that you have these similarity statements in your notes so that you can refer back to them when you are working problem. All right, what I'm going to do now is I'm going to show you some relationships within these segments of the similar triangles that always hold true. And if you can understand these relationships, then it'll help you solve problems a lot quicker. A geometric mean is a number that, when it is squared, is equal to the product of two other numbers. Okay, the geometric mean is a number that, when squared, is equal to the product of two other numbers. And so we have a bunch of geometric means in this problem, and I'm going to show you what that means. So, for example, the altitude of the larger triangle is segment Y. Okay, the altitude of the larger triangle is segment Y. And Y is the geometric mean of A and B. So what that means is that A over Y equals Y over B. A over Y equals Y over B. And if I were to solve that, I would get Y squared, because Y times Y is Y squared, equals AB. And in order to solve for Y is equal to the square root of A times B. Okay, so geometric mean. So Y is the geometric mean there. Now the next relationship is that Z is the geometric mean. So I'm going to go ahead and just start my proportion with notice that the geometric mean, they're across from each other. They're the cross products. So Z is the geometric mean of B and of A plus B. We could call that C, but for now I'm just going to write it as A plus B. So Z squared is equal to B times A plus B. And if I have values for that, then I can just substitute them in and I can solve. In order to solve for Z, I would have to take the square root of both sides. But again, you may have Z and you may be solving for A or for B. So it just depends there. And then lastly, X. X is the geometric mean of A and A plus B. So again, X squared equals A times A plus B. So I want you to see the relationships here. So the altitude is equal to, or is the geometric mean of the two segments on the hypotenuse, right? The hypotenuse is AB, segment AB. And that hypotenuse is split into two segments, not congruent, but it's split into two segments, which we're calling segment A and segment B. And so the altitude is the geometric mean of A and B. Z, which is one of the legs of the original triangle, is the geometric mean of, I want to show you this relationship here, it's the geometric mean of the closest side here and the sum of the whole side, right? The entire thing. Whereas X is the geometric mean of the closest side, which is A, and the whole thing. So they kind of have that in common. So I know this can be very tricky. We will reinforce this in class, but again, please make sure you have this in your notebook so that you can refer back to it and use it to solve problems.
I've been waiting way too long.